What is up, math superstars? In this edition of Mr. Peterson Presents, we are going to be talking about what happens when we have squares and what happens when we have roots. And so here, this objective revolves around a square and finding the area of a square. So we know the area of a square is the length times width. And so the way we can write that out mathematically is that we can write this out as 1 times 1 equaling 1. So I can say that the area of this square is 1. And so we can also write that out as 1 to the power 2 equaling 1. And so the unique thing about the number 1 is that this is actually called a perfect square number. So in a perfect square number, both sides are both whole numbers. And so we notice that we have a whole number of 1. And so we define the area of that square as just 1 times 1, giving you 1. So I can say that the number 1 is a perfect square number. So this is actually a nice, neat pattern here. And so what happens if I have this square here, both side lengths equaling 2? Define the area, I can do 2 times 2, and being equal to 4. So my total area inside of this square is going to be 4. So I can say that 2 squared, is equaling 4, and 4 would be a perfect square number. So what about 3, my side lengths being 3 on the square? I can write this out as, you guessed it, 3 times 3 equaling 9. I can also write it out as 3 to the power of 2 being 3 squared equaling 9. And you guessed it, 9 is a perfect square number. And so there's a pattern to this. You can see the pattern is I'm just adding 1 unit length to each side, giving me the next square being 4 times 4 equaling 16. So 16 is the area of this lovely square. And you guessed it, that 16 is a perfect square number. And for the next one, the pattern can continue even if I don't draw out the square. I can assume that 5, if I have one side length of 5, my other side length is going to be 5. When I multiply those two numbers together, it gives me 25. So 25 is a perfect square number. I can keep going with the pattern that you can see 6 times 6. And then you can see 7 times 7. And in your notes, it goes all the way up to 13 squared. And so that's what you're going to have to complete the pattern with imperfect squares. So now here, we're going to be given this mathematical symbol here. And so this symbol that's around the number 1, this is called a radical. And so what it's saying is, it's asking the question, what is the square root of 1? Or if I was going to write this out, I can write this out as which two numbers, when I multiply them together, is going to be equal to 1. And we notice something is that both of these numbers have to be exactly the same. And so I can say that, of course, it's obviously 1 times 1 equaling 1. So if I ask the question, what is the square root of 1? I'm just looking for one side length of the square. So I'm identifying just one side length of the square is going to be the square root. So I'll say that the square root of 1 is equal to 1. And you notice that this pattern is going to look a little familiar because underneath the radical, these are perfect square numbers. And so if I want to find out that of what the square root of 4 is, what I'm trying to figure out is which two numbers, when I multiply them together, is equal to 4, and they both have to be the same number. Obviously, it's 2 times 2 being equal to 4. And we're just looking for one side length. We're looking for one side length. So I can say that the square root of 4 is equal to 2. And the pattern will repeat. I'm looking for the square root of 9. The two numbers that I'm going to multiply together are 3 times 3 is equal to 9. And the square root is just telling me I'm looking for one side length of the square. So I can say that the square root of 9 is equal to 3. And the pattern keeps going. Which two numbers, when I multiply them together, are going to give me the perfect square number of 16? I know that is 4 times 4 is equal to 16. And so you guessed it, one side length is going to be my square root. So the square root of 16 is going to be 4. And the pattern continues. So the square root of 25 would be 5 times 5 is equal to 25. And we're just looking for one side length. So I can say that the square root of 25 is 5. I can say that the square root of 36 would be 6 times 6 equals 36. One side length is what we're looking for, being equal to 6. And the square root of 49, you guessed it, with the pattern is equal to 7 because it's 7 times 7. And you might say, Mr. Peterson, wait a second, there might be another option for the square root, maybe of 25. You might remember from integer operations that -5 times -5, because a negative times a negative will give me a positive. So actually, I can say that the square root of 25 has two answers. I can say that it is 5, but it's also going to be -5. And so, but for the sake of this video and the sake of your classwork, we're just going to focus strictly on it being the positive number, knowing that, yes, -5 times -5 will still give me the same number as positive 25. Because what happens all of a sudden now when we're given this one, this is the square root of 33. And so in this, we have to figure out which two numbers, when we multiply them together, is going to give us 33. Both these numbers have to be the same. And so you realize this isn't a perfect square number. How do I do this? So what you can do is you can put 33 in the square root of 33 in the middle. And what I'm going to do is I'm going to write two perfect square numbers on each side of it. So I can say that the bigger number, square root of 36, can go there. And the square root of 25 is going to go to the left. And what I can do is I can figure out easily what the square root of 25 is. That's 5. Square root of 36 is 6. And what I'm going to do is I'm going to estimate now the square root of 33. So I can say that's closer to the square root of 36. So I might give my estimation somewhere around 5.8, 5.9 as a really good estimate. So there's actually a way to figure out square roots just by estimating without using a calculator. So you might be given this one, maybe the square root of 90 is what this is asking. We got to figure out which two numbers, when I multiply them together, both being the same, equal 90. And you realize, man, 90 is not a perfect square number. I'm realizing I got 9 times 10. It's getting kind of close. So what I'm going to do is I'm going to use the estimation strategy where I'm going to put the square root of 90 in the middle. And then I'm going to put two perfect squares on either side. So you can see I picked 81 and 100. So I have the square root of 81, the square root of 100. What I'm going to do is I'm going to simplify both of those. So the square root of 81 is 9. The square root of 100 is 10. And now I know that this number, the square root of 90, is somewhere in between 9 and 10. And so I can figure out that, you know what, this is kind of in the middle, so I can give a really great estimation being 9 and 5/10. And so it's some strategies to figure out what the square roots of a number are if they're not perfect squares.